Today we're going to do some division of fractions, similar to what you have on your homework tonight. And there was 3 methods that we used. The first method that we learned was a method using the multiplicative inverse. So instead of dividing, we multiplied. We started with whole numbers and fractions, and we thought about it that way, but then we saw that we could apply the same thought process to any fractions, no matter what they were, because we can make whole numbers into fractions. So it's what we dub the keep, change, flip method. And we've proven this in class, so you can just do it now that we've proven it. But you take the first fraction and you keep it the same. You change division to multiplication, and because you did an inverse operation, the next number needs to be an inverse fraction, or the multiplicative inverse. And the inverse fraction is what we call the reciprocal. Fancy name for flipping the fraction over. So you do 5 over 3. And then you multiply across. So you do 2 times 5, which is 10, and 3 times 3, which is 9. You do the numerator times the numerator, and the denominator times the denominator. And I get 10 ninths. I don't like 10 ninths. I want to reduce that a little bit. 10 divided by 9, top dog in the doghouse, 10 goes underneath, 9 goes outside. 9 goes into 10 one time. 1 times 9 is 9. And when we do our subtraction, we get 1 left over, and that 1 is out of 9. So it's 1 1/9 is our final answer. And that's the first, and I think by far the easiest way, but a lot of people didn't understand that way or were confused by it. So let's go over the second way we learned, which was with a model. Okay, so with the model, my problem here is I'm talking about thirds and fifths. So when we use a model, it's a little tougher because we're not talking about the same size. We have thirds and we have fifths. We need to find what we call common denominators. So the way I find common denominators is, until you get good at it, you might have to do this first, is I list the multiples, and I find the least common multiple, which is also the lowest common denominator. So we start listing multiples of 3. 3, 6, 9, 12, 15, 18. And list multiples of 5, which are pretty easy too. 5, 10, 15, 20. Now we look at the multiples and we say, what do they have in common? Well, the lowest one I see is 15. So that's going to be our new denominator. So I'm going to rewrite these fractions with our new denominator. And since I want to write 2/3 with our new denominator is 15. So 3 times 1, 2, 3, 4, 5 is 15. Now I want to keep this expression equivalent, so what we do is we multiply by 1, because we know that because of the identity property, when we multiply by 1, it doesn't change any number. And 5 over 5 reduces to 1. So I can make the same fraction, but make it look different. So 5 times 3 is 15, 5 times 2 is 10. And on the flip side here, we have fifths, and 5 times 3 is 15, and because I want to make an equivalent fraction without changing it, I multiply by 3 over 3, and 3 times 3 is 9. So now I've got 10 fifteenths divided by 9 fifteenths. So when we draw a diagram, what you're going to do, now I want fifteenths. Fifteenths is really hard, so I'm going to do 14 lines. And I'm just going to double check my diagram, make sure I actually have 15 pieces. Oops. Okay, I have one too many pieces. That's why I always, especially when you're drawing diagrams, just double check and make sure you do your diagram accurately, because if you didn't, it's going to cause you some problems with your calculations. Okay, so there's 15 pieces, and I need 10 of them. So I'm going to use my highlighter, or you can shade with a pencil. 10 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I should have 5 left over because I have 15 spots. So it happened, so we're good. Now, because I have 10 15ths, I'm dividing them into groups of 9 15ths. So let me make a group of 9 15ths. That would be here. That's one group. But now I have a group left over, or one piece. I have a 15th left over. However, I want to split it into a group of 9. So this is where it gets really tricky. I want to split this one box into a group of 9. Okay. And I'm going to take one of those pieces. I'm going to take a 9th. So it's 1 and 1, because we have 1 left over, and we split that box into 9ths. So it's 1 and 1/9. We can also achieve this by simply using our little trick that we proved to ourselves, and we can use the same exact steps without the diagram and do something really quick. So we realized that if our fractions have the same denominators, you can completely ignore the denominators. We've proven this to ourselves on why it works. But what we can do is we can just do 10 pieces divided into groups of 9, and that's what we just did. Didn't matter if they were 15ths. We took 10 boxes and we put them into groups of 9. So we can completely ignore the 15ths and just do 10 divided by 9. So again, what we call a top dog in the doghouse. This is the top dog. He's first. He goes underneath. 9 goes on the outside. 9 goes into 10 one time. 1 times 9 is 9. You get 1 left over out of 9. So no matter which way you choose, which way works for you, your answer is 1 and 1/9. This particular example was tough, especially if you were doing it with a diagram. If you're doing it with finding common denominators, it's a little longer because you've got to find those common denominators, and this time we had to change both fractions. Sometimes we find common denominators and we only have to change one fraction, so that's not as bad. The keep, change, flip method in this case was definitely the easiest, but it's up to you. If you really like finding common denominators and just doing the long division, do that. If you really like the keep, change, flip, as long as you can remember how to do it, and remember that it's called a multiplicative inverse or a